And welcome everybody. It's great to have you here. My name is Keith Barker. Welcome to the Keith Barker channel here on YouTube. Our objective for this session is to continue on where the previous one left off. I had a live stream and I was walking through this lab in Packet Tracer, and then about, I think it was 23 minutes, just like king, and it would not connect. We've had a little overload here around the world on the internet with everything working from home and so forth. So what I want to do is I want to do part 2, the sequel of honing our skills with Packet Tracer. I'd like to share with you, first of all, a lab that I built that I'm going to have a coworker, Network Chuck, troubleshoot. And I'm going to do a live troubleshooting of that as he injects problems for the troubleshooting. So this lab, it was so funny in the previous stream, someone was saying, oh, it was like, I'm about to this end, poof, gone. So I'm recording this locally. I'll post it, and that way it'll all be here in totality. So this is the continuation of the lab that we can build in Packet Tracer. And if you'd like a copy of this lab, let me show you exactly where you can get that. You can go up to thekeithbarker.com. Let me demo that real quick. And let me see if I can grab another browser here. So if you go up to thekeithbarker.com and go down, either click on downloads or scroll down either way, and you can just right here, it's the Cisco PT for Packet Tracer, IPv4 subnets. You click on that, and that is literally the full lab that I'm going to be demonstrating today of how we can practice our skills with Packet Tracer using a lot of different features like Ospf and spanning tree and access ports and trunking and DHCP and DHCP relay and NAT and a few more. So that's the lab right there. You can grab if you want to follow along with me. And also if you want to build it from scratch, I also have a set of Packet Tracer labs as part of the master playlist. Also, let me show you where that is real quick. So if we go to youtube.com, and then we'll go ahead and search for Keith Barker. Actually, let's just do a search for 200-301. That's the exam number, if I typed it in there. That's the exam number for CCNA. And there's a lot of great resources here. So there's David Vumbel, and there's Jeremy's IT Lab. I love them. Oh, and here we go. Number 3, Keith Barker's master playlist. So if you take a look at that playlist, what I'm going to be doing is I'm adding from the top down videos as part of this playlist. So if you're new to networking, if you're new to Cisco, I would take a look at the beginning ones and just start going through them. And I'm adding new videos every week to this master playlist, so you can go to one place. Another way to get there is this. Check this out: https://OGIT. That's the original gangster of IT. .online/ and then the word sloth. You might say, well, Keith, why do you use the word sloth? Well, it's a running joke in my family about how I remind some people of a sloth the way I look, and that's totally cool. But you know what? The sloth, the thing that can help us with that is that we can use it as a tool to remember that slow and steady wins the race, like the tortoise and the hare, that analogy where the hare's all and then it takes naps and gets out of focus and doesn't win. The tortoise wins. So if we think of the sloth, think of something that's slow but consistent. And that's the way we can win the race of life, by setting our goals, moving in those directions step by step. And that happens to also be the URL for the playlist on YouTube that has all these videos in order. And as I wait for that to come up, yeah, so the internet has been, wow, interesting. But there it is. So there's the CCNA 200-301 master playlist here on YouTube. And again, you can just sort through that. And if you're new, I would recommend going through them in order. Okay, so we know 2 things. Number 1, we know how to get the Packet Tracer lab for what I'm about to demonstrate. And then secondly, we know how to go to the master playlist and start from scratch if we need to from the top and just go through them and enjoy them, have a fun time. Okay, so this is Packet Tracer. If you're new to Packet Tracer, you can get it free. Go to netacad.com. It's a Cisco training site, and you can enroll for free. Download Packet Tracer. Currently I'm using, if we click on Help and About, and currently we're using 7.3.0 and change. So if you have a newer version of Packet Tracer, you can still open the older files, no problem. But if you're using an older version of Packet Tracer and you try to open a newer file that's made with the newer version, it may not work. So just be aware that they periodically update the version of Packet Tracer, and that's the version I'm using. That's what I built this lab that's on the site, thekeithbarker.com. All right, let's picking up where we left off. Let me explain the topology and what I built here as part of a preparation for troubleshooting. So Network Chuck is going to inject some problems in this topology for me, and then I'm going to do a live demonstration of walking through it. And I believe he's going to have some doozies for me. So starting with the ground up, we have a PC connected to an access port right here on a switch. So if we click on that switch, we learned in one of our videos regarding VLANs and trunking that a switch supports layer 2 VLANs. And so if on this switch, this is at the CLI, if we do a show, let's do a show Vlan Brief. It's a great command, and I will extend this over a little bit. There we go. So this is showing us that for this access switch, it's got a whole bunch of ports that are assigned to VLAN 1, which is the default, and it has these two ports right here, FA0/1 and FA0/2, which are associated with VLAN 10. That means this PC, which is on one of those ports, and this server, which is on another one of those ports in VLAN 10, are both in the same VLAN, the same layer 2 network. That also means, well, same layer 2 broadcast domain. That also means they are both on the same IP network. So at layer 3, we have IP addresses. At layer 2, we have layer 2 VLANs. And normally, unless we're doing something tricky, we're mapping a layer 3 network address into a VLAN. So it's like a street name. So every VLAN has an associated IP network or network ID or a street name associated with it. And that's how these two are carved out. And if we go down, also this link here between the access layer and the multi-layer switch, if we do a show interface trunk, another great command, it'll show us the trunks where we're using 802.1q trunking. And again, if you're new to these topics, no worries. Just start with the master playlist, start going down them in order, and then we'll be covering each and every one of these topics that are already there in that playlist. So we're doing some trunking, and you'll notice here it says that and we can also show the ports. If we go to view, options and preferences, one of the options in preferences is to go ahead and show the ports. So always show ports or not show ports. We can also use CDP, Cisco Discovery Protocol, to identify who we're connected to. So on this access layer switch, if we did a show CDP neighbors, Cisco Discovery Protocol neighbors, it shows, hey, on gig 01, we're connected to MLS1. And on our gig 02, we're connected to MLS2. So that's how we can read that. All right, so we have, on this switch, we have some access ports that are carved out. We have trunking. What else do we have on this switch? Oh, on this switch, we also have a management IP address. So that way, an administrator can remotely connect to that switch using its IP address to go ahead and talk with it. And to see that, we could do a show IP interface brief. And we go all the way to the bottom. There is a VLAN 7 interface. So a VLAN interface is a switched virtual interface. It's a logical layer 3 interface that we can use for this box, this switch, to go ahead and communicate locally or with other devices over IP. So even though access layer switch number 1 is not doing IP routing for other devices, it is able to be managed. And along with that, let's see if it has a default route. So our default gateway, show IP route. Show. Why? Let's do a show run. Oh, look at that. This switch doesn't have a default gateway configured. So that's my bad. So if we want to talk to this switch on its IP address, if we're local on that VLAN 7, we can go ahead and talk to it. But other than that, it doesn't have a default gateway. So that's something else we might want to add. IP default gateway, and then we'll point to whatever the default gateway is, 10.67.83.1. Show default gateway. Show. There's got to be a way to see this real quick. Hold on a second. Show. Wow. Okay, so other than doing a show run, it doesn't occur to me right here in Packet Tracer how we can view the default gateway, but there it is with the show run. And let's verify we can ping that. Ping to 10.67.83.1. Yeah, there we go. All right, so I did not configure that as part of this lab, so that means that if we want to remotely connect to this access layer switch, it would be proper to give it a default gateway so that it can remotely connect to administration workstations and management sessions that are not just local. All right, well, live and learn. All right, so moving on, what else do we have here? So I've got PC1 and the server in VLAN 10. This PC over here, HQ2, if we click on this access layer switch on the right and go to the CLI, again, it's just an overview of some of the things that are in this lab. If you want to download and look at it yourself, that'd be great. We'll just show Vlan Brief. And this has got one port in VLAN 20, which is FA0/1, which is where that PC is. And for these PCs, if we hover over them, let's go ahead and hover for a moment. If we hover over it, it's going to show us the IP address. And it got its IP address via a DHCP server. So what I did was I used DHCP to assign the addresses to PC1 and PC2. They're in 2 different VLANs. So on the server, I went in, and under services, I enabled DHCP services. So here, if we go to services and DHCP, I have 2 pools. I've got the default pool, which is in the VLAN 10, and I've got VLAN 20, which has IP addresses for VLAN 20. Also, I did a subnet Saturday where we decoded the subnets involved with this specific topology. If you want to see that, it's in the playlist. Also, if you're new to IP subnetting, please feel free to start at the beginning of the playlist for IPv4 subnetting. We call it Subnet Saturdays, and that'll take you all the way up to speed with the various ranges and how to set them up. Now, the problem with this DHCP server is that it's sitting here in VLAN 10, so to make this work, we need somebody listening in VLAN 20 for DHCP clients so they can take those requests and forward them over to the DHCP server, which is not local. And so I've done that here on the multilayer switches. So on the multilayer switches, if we go to MLS2 for a moment and we do a show IP DHCP, oh, there we go, relay. Love it. Oh, it wants details. Oh, well, let's do this. So show IP interface for VLAN, and it's going to be VLAN 20. So there's the IP information for a lot of output here for VLAN 20, and I'm looking for, oh, I shouldn't be in a rush. So let's do this. Let's do a show run interface. Let's do a show run. So on a real router, you could just show run and then specify interface VLAN 2 or VLAN 20. Yep, it doesn't like that. So we'll do a show run, and let's do a pipe section interface. There we go. All right, so there's interface VLAN 20 right there. And here's the IP helper address, which is the DHCP relay, which is basically taking any DHCP discover messages and shipping them over to the DHCP server so the DHCP server can respond to them. So that's the DHCP helper function. That's working as well. I also have trunks between access layer switches and the MLS. I've got trunks in between them. Also, coming down here at the very bottom, I've got trunks from the multilayer switches down to this router. And you might say, well, Keith, how come you have trunks down to a router? You're not doing router on a stick, are you? No, I put a module in, a switch module on router 1. So if we open up router 1, check this out. I wanted some fault tolerance, and I didn't want to have to use 2 different networks to do it. So this is the physical interface, or the physical view for this router, and I added this switch module right here. And I just basically dragged and dropped the module over, and then it has switch ports. So I made a VLAN that supports just those 3 devices. I think we can take a look. Show Vlan Brief. Yep. I made this VLAN called VLAN 30 with a VLAN interface for VLAN 30, and MLS1, 2, the 2 multilayer switches and the router are neighbors on that. So we just show IP Ospf neighbors. There's the VLAN 30 neighborships right here at the bottom. And so that way, if either one of the 2 switches fails, or if either of the 2 links fails, one at a time, we can still have connectivity to the outside world. All right, so again, just talking about the technologies that we've used here. I'm also using Ospf. If we do a show IP protocols, and here's my network statements on R1, and this basically says any interfaces that start with 106783, I want them to be in part of Ospf, process ID 1, area 0, and any interfaces that begin exactly with 1111, which is the loopback, I wanted to include it on R1. So that's the Ospf part. I also did Nat right here on R1. We do show IP Nat Statistics. That'll give us a nice picture. So the IP Nat Statistics shows us which interfaces are outside, which interfaces are inside, and also it shows us the pool, it's called 4NAT, and shows us the range. And if we do a show IP Nat Translations, no translations in place, but if we do a show run, let's do a show run. Let's look at the NAT section real quick. Almost there. There we go. So here's our NAT pool. And there's the access list. And there's the access list. So we're calling on an access list that says if traffic matches 1067.83 anything, it's going to go ahead and be natted into the pool called for NAT, and that is the range for that pool right there. So if we went to a PC like this guy, and we opened up a browser, so to do that, we could go to desktop, and over here on the right, let me bring it down so you can see it. There we go. So right here we have web browser, and this server, this public server, if we hover over it, it'll show us the IP address. It's 23.1.2.2.2. 23.1.2.2, and we'll go back to this client and we'll open up a web page to 23.1.2.2. Now this also implies that routing is in place. I've got routing in this entire network functioning. So when the headquarters PC1 sends a packet, it says, oh, it's not a local network. It has a default gateway. It learned it via DHCP, and click on go, and there it is. Also, if we look at this PC, and we go to config, well, we can do it here, that'll work. See how it has a default gateway of 1067.83.4? That's a virtual IP address that's being supported in VLAN 10 with HSRP, which is also running in this topology. Yet another, and the cool thing is, check this out. This is so cool. Right now, if we did a trace, let's do that. Let's go back to desktop. We'll close that, go back to a command prompt. If we did a trace, so on Windows, on a Windows computer, trace RT, and they've emulated that here. We'll go to 23.1.2.2. We'll do a Control C there. So I put 2.2. So this is a trace from this PC down through the routers, down to the public server, and I just want to see what path it's taking. So even though this PC has a default gateway of 83.4, the actual router that's supporting that is router 1, because that's who responded back with the ICMP as part of the traceroute command. So the path we're taking is from the headquarters PC, going through the switch network, down to the layer 3 interface of VLAN 10 on MLS1 based on this IP address, and then that's being routed to router 1, which is at .43, and then it's being finally forwarded to the public server. So what was I going to show? I got excited. What was I going to show you there? Oh, we should have some Nat translations here on the router. So on the router, if we do a show IP Nat translations, there's our translations. There's some for the pings. Now in trace RT on a Windows computer, it actually uses ICMP. So these would be from the trace that we did, these first three here. And then this guy right here is the HTTP session that hasn't timed out yet from that PC down to that server. So routing is in place. If we do a show IP route Ospf, that'll show us all of our Ospf learned routes, and that I also implemented. Then for the WAN, I wanted this to look like a layer 2 network of VLAN from the headquarters router out to the site 1 and site 2, or site A and site B. And so I just put a generic switch there, and then I connected the routers, gave them an IP address based on that WAN topology, and then I used DHCP on these two routers, site A and site B, and they're handing out IP addresses to these two PCs. So if we went to this PC, we can hover over it, shows us the IP address. But if we wanted to do let's go to command prompt, and let's do a trace to, let's go up to the, let's go to this internal server. I'm going to hover over it for a moment. The internal server is at 10.67.83.3. That'll be good. So 10.67.83.3, and that'll show us the path. I made that full screen. Let me bring it over here. So that'll show us the path that it took. So it went to, the first hop was .65, which would be the local router, and then it went to 51, which would be R1, then went to 41, which is going to be one of these two multi-layer switches, and then it finally ended up at the server at .3. So those are just a few of the technologies that I've implemented as part of this packet tracer lab. And then spanning tree also, I tweaked that also. I made this switch right here. I made it the root for VLAN 10. I made MLS2 the root for VLAN 2. A big party going on. And you can verify all that. So what I would encourage you to do is, if you're new, and you go to the big screen. If you're new to Cisco networking and you want to get good at it, you want to get certified, I would encourage you to get a good book. You can go to Amazon and just look at the reviews, see what books are good. find some content that works for you as far as written material, video, and also for hands-on practice, it's hard, really hard to beat Packet Tracer at the CCNA level because it installs in moments. You can drag and drop gear, switches, and everything else on your topology in moments. You can configure it all, and then you can get the hands-on practice. So when we do a show IP protocols or show IP Ospf, or if we do a show IP interface, it doesn't matter if that response coming back is simulated like it is in Packet Tracer or if it's on live gear. All we want is the experience of how it looks and feels, and Packet Tracer does a great job in doing that. So thanks for joining me in this sequel about using Packet Tracer to hone our skills. And again, if you need to backfill any of this information, I would encourage you to go to the Keith Barker page on YouTube, start at the beginning of the master playlist, and just go down in order step by step by step. And every opportunity where you want to learn it better or master it or confirm it in your mind, I encourage you strongly to go ahead and use Packet Tracer to lab it up. So I'm going to be adding some Packet Tracer labs as we go to spice up the playlist as well. So you have a chance to actually from the ground up build these labs or take a framework that I have on my website so you can go ahead and just start it that way and get the hands-on practice. So thanks for joining me in this video about honing your skills with Packet Tracer. And I think from this demonstration we've seen how many technologies we can refresh and learn about in one fairly simple topology. And the secret is this: if you're new to it, you don't need to start with the fault tolerance. You don't need to have two. In fact, let me show you real quick. You don't need to have fault tolerant everything. What we could do is this, and this might be a good start. So I'm going to save new, and I'm not going to save the old one. And let's imagine you want a PC. So down here, you go to network, you go to end devices, bottom left-hand corner. You check my view here, and then just click on the device you want. Well, I like a laptop. Boom, there's your laptop. And then maybe we'd want to switch. So we click on network devices right here. And then we'd click on the little switch icon on the bottom left and then say, let's get a 2960. It's a pretty basic little switch. Great, there it is. You can rename these two, no problem. And let's drag up a router. And so you click on router and then grab the router you want to bring, drag it up. And let's also put one more switch in place. Go back to switch. And let's bring up a server. And so we go back to end devices or network devices. End devices right there. And then we'll grab a server. And so in just literally a few moments, you can have that topology. If you're new, you can use the lightning bolt as a connector tool and then click on lightning bolt again and just connect them together. And click on the connector tool again, the auto connector, and it will select the right cables for you. So if you haven't learned, do I need a crossover yet? Do I need a straight through cable? Don't worry about it. That'll give you your connections for you. This router is down by default. The interfaces are shut down, which is what would happen in a live environment. So then you can go ahead and bring it up. Just go to the router and go to the CLI. And let me scooch this over a little bit. And here we go. I'm going to bring that down up here just to give us a little more room on the right to go ahead and see. So if we go to the router, this is what the router looks like when it boots up. Would you like to do the initial config, initial dialog? No, I wouldn't. We'll go into privilege mode, change the host name. Just wash my hands, can't do a thing with them. Host name, we'll call it R1. Maybe we go over here also and rename it R1 so it matches, so we don't get mixed up on what device we're on. And then we'll go to our interfaces. If you're not sure what the interfaces are, we can go to View, or Options rather, and Preferences, and say, please show me the port labels. Great. We'll close that. And now we can see that that is gig 0, 1, and 0, 0. So we go back to that router. And we simply do a no shut on those interfaces. Interface gig 0/0, no shutdown. Let's use IP address 10.0.0.1. And it probably wants a mask on that. So we'll put a mask on that. And then no shutdown. If I didn't already, I already did that, but it's okay. And then interface gig 0/1 is the other interface. And we'll do a no shut there, no shutdown. And that's a different network. So we can't use 10.0.0 because that's one network. We need a different network. Let's use IP address 10. Let's call this 1.0.1. So the first network is 10.0.0. This network will be 10.1.0 with a 3-octet mask. Join us for Subnet Saturdays if you need to brush up on what masks are, what they do, how that operates. And then what we can do is we can configure the server. So let's take a look at our interfaces. Show IP interface brief. So 00 is the 10.0.0 network, and 01 is the 10.0.1 network. And let's go ahead and put some IP addresses on our server. So over on this side is going to be 10.0.0, or on this side is 10.1.0. So on our server, we can go ahead and go to config, interface, and we'll specify that we want a static address. Let's use 10.0. 10.0.0. Let's use 2. And we'll use the same mask because we're on the same street. So a 3-octet mask. And I'm also going to put a default gateway in here. So I'm going to do that here under settings. And the default gateway is 10.0.0.1. Otherwise, if we don't have a default gateway, that server can only communicate with local devices on 10.0.0. It won't be able to route over to laptop 0. So we'll put that in, close that, and then we'll go over to the laptop. And this is the 10.1 side. So we'll go to config, interface FA00 on this device, 10.1.0. Let's use 2, and the same mask as the router. So this is the 10.1.0 network, and the default gateway would be great too. So 10.1.0.1, and we're not going to worry about DNS for this discussion. All right, so let's just hover and make sure we got this right. So server 0 is 10.0.0.2 with the default gateway of 10.0.0.1. Great. The router has 2 interfaces, gig 00 at 10.0.0.1 and 10.1.0.1, and then the laptop should be 10.1.0.2, and it has the default gateway of 10.1.0.1. Then to test it, this server in Packet Tracer, if we go to Services and HTTP, it is on by default. It's a web server ready to rock. So we can go to this PC, and from the PC, we can just go to Desktop and scroll over just a little bit to the web browser, and then go to 10.0.0.2 was the address, and go. And then we troubleshoot. Hold on a second. Let's check the IP addresses. What did I do wrong? I did something wrong. 10.0.0.2. Default gateway 10.0.0.1. Laptop 10.1.0.2. Default gateway 10.1.0.1. Router 10.0.0.0 on gig 00 and 10.1.0. That looks good too. And the interfaces are up. All right, let's try that one more time. Let's go back to the laptop. It's a lot like the real world, by the way, when things don't always go right the first time. And let's go to 10.0.0.2 and click on Go. All right, well, you know what? This just turned into a troubleshooting lab. Here's how we would troubleshoot this. I would say, well, let's go to this PC and verify we can ping our default gateway. So maybe I messed up something there. So I'll click on the little X there. We'll go to command prompt. And let's do an IP config. So the IP address is 10.1.0.2. The default gateway is 10.1.0.1. Let's verify we can ping that. 10.1.0.1. Can I ping my default gateway? And I cannot ping my default. Oh, look at that. That's totally. I got the interfaces flipped. I thought gig 00 was going over to the right and gig 01 was going to the left. I got them backwards. So Packet Tracer is not misbehaving. I got the interfaces absolutely flipped. So let's solve that. And we can also test that. We go back to router 1. We can do a show CDP neighbor. And that's, I have both switches named switch. That's their host name. So if we had the right names on the switches, it could actually help us verify which is which. So let's go ahead and flip the IP addresses. Config T, interface gig 0/0 should be IP address 10.1.0.1 with a 24-bit mask. Oh, great. All right, let's do this. All right, so let's see if default works. Default interface gig 0/0. Great. And we'll do a default interface gig 0/1. That's going to wipe them back to their defaults. Great. And then we'll do a IP address 10.1.0.1. I need to make sure I'm in the right interface though. Gig 00. Let me make sure my PC is on the right subnet. So 10.1 is on the left, and that is the gig 00 interface. Great. So gig 00 and IP address 10.1.0.1. Interface gig 0/1. And that's going to be the IP address 10.0 on the right. And let's verify we can ping. So I'll verify I can ping 10.0.0.2, which should be the server on the right. Ah, that works. And then we'll do a ping 10.1.0.2, which is the PC on the left. So what we have now is we have the correct networks configured. We have the laptop with a default route pointing to R1. We have the server pointing as a default route to R1. And now if we do go to laptop and try that ping to 10.1.0.1, let's do an IP config just to remember what IP address I have. My local address is, okay, so I can ping my default gateway. That's great. Let's go for the full shot over to the server at 10.0.0. I pressed enter too early. 0.2. All right, there we go. All right, and that's working. And so we got a little bit of troubleshooting in along with that. But my gosh, that is one of the benefits of using Packet Tracer and labbing this stuff up, is because the more practice we have in seeing it and encountering challenges, even if we cause them ourselves, it gives us the opportunity to practice it, work through it, and then the next time we build a lab, we're probably not going to make that same mistake. We'll make better documentation, better planning, whatever it is, and we can continue to grow our skills. So thanks for joining me in this video as a demonstration of how we can use Packet Tracer to hone our skills in the world of Cisco networking, and I'll see you, my friend, in the very next video. Thanks, everybody.